Hello and welcome to another thrilling installment of the geometry videos, and this is a unit 6, and this is about right triangle relationships and trigonometry. Okay, so we're going to have a lot of conversations about using trigonometry and right triangles. We're going to focus on that for unit 6. So, what we want to do is be able to classify triangles using the Pythagorean theorem, and then, use the Pythagorean theorem to solve problems and determine an unknown side or range of side lengths of a triangle given its classification. So the first thing we need to talk about and understand is that I have a friend. Okay? Now, I consider Jim Smith to be my friend. However, many Friday nights roll around and I ask him, "Hey, Mr. Smith, what are you doing tonight? Why don't we get some burgers and, hang out and let's, have a nice little evening together." And then, and that's like on a Tuesday. And he says, "Yeah, Joe, that's fine. That sounds great." So, every day leading up to that, I'm saying, "Hey, what do you want to do Friday afternoon? Where do you want to go? What do you want to do?" And, we talk about possible ideas. And then all of a sudden, and it seems to happen every week, but every Friday he comes up to me and he says, "Hey, sorry I can't make it. I got to do something with my wife or my daughter or something like that." And, it hurts me, badly. However, I say, okay, because I have another friend that I can hang out with, and his name is Pythagoras. Okay, he is always going to be there for you. He's never going to, to go away. He's always going to, be a friend. Okay, so, given a right triangle, all right, what I know about that, the relationships in a right triangle, and I'm going to call these lengths here and here legs, okay, like Lieutenant Dan's magic legs. And then I'm going to call the side that's opposite of the right angle, okay, here, I'm going to call that the hypotenuse, okay, hypotenuse, okay. And what I know is that if I take the length of A, okay, and take length A and I square it, okay, and if I take length B, add it to length A, then that's going to give me length C squared, okay? And an example of this, okay, an example would be something like the most basic triangle, which is a 3, 4, 5 right triangle, okay? If I take 3 squared and add it to 4 squared, it's going to give me the length 5 quantity squared, okay? So 3 squared gives you 9, 4 squared gives you 16, 5 squared gives you 25, and so 9 plus 16 gives you 25, and these are equivalent values, and so it works, okay? So, this is your most basic right triangle, the one that you will probably need to remember the most, okay? But, that is the Pythagorean theorem, that if the squares, the sum of the squares of the lengths is equal to the square of the hypotenuse, okay? A squared plus B squared equals C squared, okay? And then we have this converse, and it says if the square of one side of the triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So if you're given a triangle and you're trying to figure out if it's a right triangle, use Pythagorean theorem to see if it does that, okay? So let's go ahead and figure that. We already did it. Okay, so, let's use this to determine whether this is a triangle. Okay, take your two shorter sides, 3 squared plus 4 squared, is that going to be equal to the longest side, 5 squared? Okay, so 9 plus 16, is that equal to 25? And so then you get 25 equals 25, and that's true. Okay, so this is a right triangle. All right. The other one, okay, let's try this one. Let's see if this is a right triangle. Okay, let's take the two shorter sides, so 4 and 9. Okay, so 4 squared plus 9 squared, is that equal to 10 squared? Okay, and so we end up getting that this is 16 and this is 81. Is that equal to 100? Okay, 16 plus 81 is actually 97. Which is not equal to 100. So this is not a right triangle, okay? So you got to use Pythagorean theorem to verify if it is a right triangle, okay? And I can come over here and put a right angle in there, say it's a right triangle. Okay, so what I know is that here's what I've got. If I can say, how can side lengths be used to classify a triangle? So what I know is that if this relationship works, if I take a squared plus b squared, and that's equal to c squared, okay, then it is a right triangle, okay? So this is a right triangle, all right? Now on the other one, okay, if I were to take, say, a squared and plus b squared, a squared plus b squared, notice that the third side is much longer, okay, than, say, c, all right? Then that would be, what do I have here? What is it? Is it, I gotta remember, acute, it's when that's bigger. Okay, so the sums of these sides would be less than, say, the sum of, say, the length c squared, okay? This would be an obtuse triangle. All right? If I had, because I have one obtuse angle here, okay? If this other length here, you know, if I take length a squared, a and b, if I take a squared plus b squared, then I know that that side is greater than that side c squared. Then I have an acute triangle, okay? So that's the idea, all right? So that, and those theorems are written down here, all right? So, you know, and let's just think of an example here, all right? Let's just say that this is a length of 3, this is a length of 4, and we'll call this a length of 4, okay? And so let's just, actually, no, let's not do that. Let's do, call this a length of 6, 8, and 9, okay? Now, if I take 6 squared, or 8 squared plus 6 squared, 8 squared plus 6 squared, what's the relationship in that between 9 squared? Okay, and this is an acute triangle, okay? So if I were to take, say, 8 squared, that's going to give me 64, plus 6 squared, which is 36, and then 9 squared is 81, okay? Then I take these two shorter sides, you know, the squares of them, add them together, that's going to give me 100. And then I have 81. Because the length of the two smaller sides, when I square this, is larger, okay, this is large, okay, other than that third side, then I get an acute triangle. So it's a way for us to identify, you know, the type of triangle that we get, all right? Same thing with an obtuse triangle, all right? If I call this, say, 6, 8, and we'll call this, say, 12, all right, and I get, say, you know, 6 squared plus 8 squared is going to be less than, say, 12 squared, all right? 6 squared is 36, 8 squared is 64, is less than 144. So you end up getting that this is 100 is less than 144. So if the third side is large, okay, larger than the sum of the two other sides squared, then you have an obtuse triangle. Okay, and that's it, all right? So let's go ahead and apply that idea, and let's just kind of figure out what we can do from there. And what I want to do is classify the triangles as acute, obtuse, or a right triangle. So what I'm going to do is I'm going to take the two smaller lengths, okay, so I'm going to take 3 squared plus 7 squared, and I want to know what's my relationship between that and my third side, 8 squared. Okay, so 3 squared is 9, plus 7 squared is going to give us 49. What's the relationship between that and the third side, which is going to be 64? Okay, if I take 9 and 49 and add them together, that's going to give me 58, okay, which I know is going to be less than the length of 64. Okay, so my long side, okay, my longest side was large, okay, this part was large, okay, larger than the other two sides. So because that third side, the longest side, the square was larger than the sum of the squares of the other two sides, then this means that I have an obtuse triangle. Okay, and that's it. All right, let's take a look at an application problem and see what we can do here. All right, and so we have this application problem where we have this person named Jax. Okay, I think that's a cool name. I think if I get a dog, I'm going to name it Jax. Yeah. That's cool, right? Yeah. Okay, so Jackson's setting up an obstacle course for his campers in the shape of a triangle. The distance from the first to second obstacle is 60 feet. And from the second to the third obstacle is also 60 feet. So the other question is how far can he place the third obstacle from the first so that the course is an obtuse triangle? So what we want to do is we want to say this, okay? Obviously, this is going to be our longest side, okay? And so what I want to do is say, all right, if I take these two sides and square them, so if I take 60 squared plus 60 squared, okay, in order to be obtuse, we need to have a length here, which we'll call c squared, that needs to be larger than the sum of these two, okay? So what I'm going to do, 60 squared, that's going to give me, I believe, 3,600, so 3,600, okay, plus 3,600 needs to be larger than c squared. Okay, so if I take two of those and add them together, that's going to give me 7,200, okay, which is going to be larger than, say, c squared. Okay, and if I take the square root of both of those sides and solve for c, that's going to give me approximately 84.85. Okay, so 84.85. Okay, so the value for c needs to be larger than that. Okay, so you could place the third obstacle approximately 84.85 feet away. Okay, so this needs to be longer than 84.85 feet. Okay, in order for this course to have an obtuse triangle. Okay, so we kind of just have to, apply what we knew about that other third side, okay, to knowing that this would have to be larger than the sum of these two squared in order to give me an obtuse triangle. So I hope this made sense. Hope this isn't too bad for you. And just remember, guys, Pythagoras is your friend, a very dear friend.